everyone. Hopefully you're doing well. We are at the end of chapter 5, exponents, polynomials, and polynomial functions. In this particular section, 5.8, section 5.8, we would focus on solving equations by factoring and solving problems. In the previous sections, if you missed anything, I would strongly advise you to go back and watch videos that covered section 5.1 through 5.7, going through exponents, scientific notations, polynomials, polynomial functions, multiplying polynomials, the GCF, greatest common factor, factoring by grouping, factoring trinomials, factoring by special products. And now we would go ahead and solve equations by factoring and solve all the problem. Okay. The objective for this chapter would be mostly to solve polynomial equations by factoring, solve problems that can be modeled by polynomial functions, and find the x-intercept of a polynomial functions. So in these sections, we would focus, your effort to learn factoring starts to pay off. What we're going to do is to use factoring to solve polynomial equations, which in turn help us solve problems that can be modeled by polynomial functions and helps us sketch the graph of polynomial functions. Now, in terms of polynomial equation, the polynomial equation is the result of setting two polynomials equal to each other. Okay, equations that set two polynomials equal to each other. That's might be anything. For example, if you have, for example, 3x squared minus 2x squared equal x squared, equal x squared plus 2x minus 1. So if we have something like that, that's an examples of, polynomial equations. So, a polynomial equation is in standard form if one side of the equation is 0. So instead of from the polynomial, I can just move all those terms to one side. For example, if I have x squared I'm sorry, I said x cubed. That was 3x cubed. If I said 3x cubed minus 2x squared, and if I bring the other term to this side, and plus 1, I equal to 0. So if I simplify 3x cubed minus 3x squared, minus 2x plus 1 equal to 0, we said at this point the equation is in standard form. So when the equation is in standard form, on the right, or either on the right or on the left, it's equal to 0. Say polynomial equation is in standard form if one side of the equation is equal to 0. So the degree of a simplifying polynomial equation is in standard form is the same as the highest degree of any of its terms. So a polynomial equation of degree 2 is called quadratic equation. For example, if you have any polynomials in the form ax squared plus bx plus c equal to 0, we said it's a quadratic form. So quadratic equations is any equations like 2x squared plus 5x plus 4 equal to 0. We said any equations like this is is a quadratic equations. If a solution of a polynomial equation in one variable is the value of the variable that makes the equation true. So the method presented in this section for solving polynomial equation is called the factoring method. So this method is based on the zero factor property. If zero factor probability, for example, if A and B are real numbers, and if AB equal to zero, then A equal to zero or B equal to zero. This probability is true for three or four more factors. For example, if I have 2x plus 1 times x minus 5. You see, because I have two parentheses, I can set each of them equal to 0. And so I said 2x equal to 0 if I subtract 1 from both sides. Because when you solve, you isolate the variable on the one side and the constant on the other side. Now, you need to divide both sides by 2 to make sure that you obtain only x, that is negative 1/2. So this is the answer for the first equations. Remember, we said it's either 2x plus 1 equal to 0 or x minus 5 equal to 0. So if you add 5 to both sides, okay, so you're going to have x equal 5. Now you have two answers that you can go back and check in the original equations. If the answer uh, showed that left equal right, then you're going to leave it like this. So if it's not, then you would say there is no solution. In this case, because it's only polynomials, so we know the solutions would be negative 1/2 and 5. I try to go over an examples very quick with you because, it's the last sections. We want to have fun at the same times, do our best for it. So one of the examples you can see here, because it's a factor, when you have a parenthesis times another parenthesis, you can say you have a product of two factors. So you can set each factor equal to 0. The first thing is to verify that it's multiplication sign. There is no divisions or there is no positive, plus or minus between the parentheses. And you need to make sure on the other side, it's 0. So if you said x minus 4 times x plus 2 equal to 5, you cannot set each of them equal to 5. The only way to solve these equations, you need to make sure this side right here is 0, okay? So what you do, you set x minus 4 equal to 0. If you add 4 to both sides, you obtain x equal 4. And if you set x plus 2 equal to 0, if you subtract 2 from both sides, you end up with x equal negative 2. Those are the two answers you obtain when you do that. You can check the solutions on your own, like plug it back in the original equations to make sure the left side will be equal to the right side. Otherwise, you can state the solutions by writing both answers in a bracket like this one. Now, other things we can do is with example 2. With example 2, now, as you can see here, it's very difficult to solve these equations the way it is. You cannot just go ahead and solve these equations the way it is. It's a quadratic equation, but at the same time, you need to apply all the techniques we learn on how we need to factor trinomials. I cannot say that x squared minus 5x equal 24, like, just solve it like this. I need, first of all, to make sure I bring all the terms on one side. When I bring all the terms to one side, I need to set it equal to 0. For example, here, I can subtract 24 from both sides. Now, let's suppose I subtract 24 from both sides. I end up with x squared minus 5x minus 24 equal to 0. Now, when we factor trinomials, we told you that two numbers, if coefficient of x squared is 1, okay? If coefficient of x squared is 1, you need to find two numbers when you multiply give you negative 24. When you add them, give you negative 5. So what we do, remember that, we're going to two numbers when you multiply give you negative 24. When you add these two numbers, it would give you negative 5. Can we go ahead and check these answers? Now, because the two numbers when I multiply give me negative 24. I know 2 times 12 give you 24. Uh, 3 times 8 give you 24. 5 minus 8. Oh yeah, so we need to take negative 8 and negative 8 and 3. So when we add negative 8 with 3, it gives you negative 5. So we can factor this trinomial using these two numbers, x minus 8 times x plus 3. Before you solve any quadratic equations, you need to make sure that you bring all your terms on one side. Then you use one of the techniques I already taught you about on how to factor trinomials. Then to factor it, if the coefficient of x squared is 1, you can just go ahead and use two numbers. When you multiply, give you C. When you add, give you B. Then you factor it out. Now, we're not done. We just factor the trinomials. Our goal is to solve the equations. In order to solve the equations, we definitely need to set each of them equal to 0, meaning x minus 8 equal to 0. If you add 8 to both sides, it would give you, x equal 8. That's your first answer. Then we go with the second parenthesis. Remember, a product of two factors equal to 0. You need to set each of them equal to 0. So after I set up, I make, x minus 8 equal to 0. I can also do x plus 3 equal to 0. When we subtract 3 from both sides, we know x would be equal to negative 3. Now, again, go back to the original equations to check the solutions on your own, or you can just state the answer if you already understand everything. Let's say we state the answer, negative 3 and 8. And that's it. Those are the solutions. Now, let's suppose you understand this example. I would love to leave the third one for you, but let's do it that way. Now, you see, each term on the left has a coefficient. We have 3, negative 29, and 30. Do you think, is there any common factor here that we can call GCF, the greatest common factor? Yes, I know 3 times something give you 30, so 3 and 30 has a common factor, but 29 is a prime number. So prime number only has two factors, one and itself. Now, we cannot do it. In this case, remember the AC methods we learned in one of the previous section that we call the AC methods. The AC method is to identify A is 3, B is negative 29, C is negative 30. Now, the AC method tells us if we multiply A by C 3 times negative 30, that would give us negative 90. Now, what are the two numbers? When you multiply these two numbers, it gives you negative 90. But when you add these two numbers, it's going to give you negative 29. So think about it. Two numbers when you multiply give you negative 30, but when you add, give you negative 20, negative 29. Yeah, that's how we're gonna do it. We can try multiple ones, First of all, find all the factors of 90. If you have 90, you know 10 times 9 is 90. Or the easiest one to go is, if you have 10 times 9, you have 30 times 3 is also 90. If you do 2 times 45, okay? So we can go with this one very quick, okay? You have the other numbers because that's one gonna help us to do factoring by grouping. Now, again, we need two numbers when we multiply, give you the 3 times 30 is 90, right? Negative 90. What are the two numbers when you multiply, give you negative 29? One of them must be positive, the other one must be negative. So if we do 6 times what? 3 times 30 give you 90. Okay. If we have um 90, do we have a 45 times 2 give you 90, right? Do you have 4 times something? 4 times 18 give you 90. Okay. So it would be very not simple for this one to find two numbers when you multiply give you the AC method. So what we're going to do, we can do a factor, we can do trial and error. So what I'm gonna do most of all here is to make sure that I find two answers. So what I would do, I know 3x squared can be written 3x times x gives us 3x squared. But look, if I take, because the goal is to find negative 29. So if I put negative 10 here and 1 here, you see we have negative 30x plus 1x. That gives you negative 29x, which is determined in the middle. So I try to do the AC method first. If the AC method looks a little bit complicated, doesn't mean it's impossible, but it might look a little bit complicated. So what we do, we use the trial and error methods. Now with a factor, we can set each factor equal to 0. Subtract 1 from both sides, it gives us 3x equal negative 1. Divide both sides by 3, x would be negative 1/3. The same, because we have two factors, x minus 10 equal to 0. If you add 10 to both sides, you end up with x equal 10. Those are the two answers. Because we deal with polynomials, remember with polynomials, the best you can do is just set the answer because we know the left side would be equal to the right side. Okay. Is that okay? Now, how to solve polynomial equations? We can use different techniques on doing that. To solve a polynomial equation, the first step is to write the equation in standard form so that one side of the equation is equal to 0. Factor the polynomial completely, no positive, negative, or division sign between the parentheses, only multiplication. Solve the resulting equation by setting each factor equal to 0. At the end, once you obtain an answer, you check each answer in the original equation to make sure this left side equal the right side. Then you set the solutions. Remember, not all answers are solutions, right? You can solve an equation, you obtain an answer. The answer is not the solutions. Now you need to verify it first in the original equations. If it's verified, then it's become a solution. All right. Example 4, we see that we have x times 5x minus 7 equal negative 2. For these equations, if you had only x times 5x minus 7 equal to 0, you could set each factor equal to 0. That means x equal to 0 one time, and then you would do 5x minus 7 equal to 0. But the problem is not equal to 0, it's negative 2. The first step is to distribute the x, that means x times 5x give you 5x squared. X times negative 7 give you negative 7x equal negative 2. We need to rewrite it and then, try to get all the terms to one side. Now, if I add 2 to both sides to make sure the left side equal to 0, then we have 5x squared minus 7x plus 2. You can do either two numbers when you multiply. If you want to do AC methods, it's fine. Like you set, I'm gonna try this again. If A is 5, B is -7, C is 2. If you do AC method, you do 5 times 2 is 10. Now, what are the two numbers when you multiply give you positive 10? When you add these two numbers, it give you -7. Factors of 10 is -2 and -5. -1 times -10, 2 times 5, 1 times 10. So because C is positive and B is negative, we know the two numbers must be negative. So we're gonna go with -5 and -2. -5 times -2. So we go back, we can do 5 is rewrite it as 5x squared. Instead of having -7x, we can rewrite it as -5x minus 2x plus 2 equal to 0. 5x squared minus 5x, we can put these two together, minus 2x minus 2, I bring the negative outside. Factor, we can factor 5x, so we have only x plus 1 left. Sorry, x minus 1 left. We can factor 2, we have x minus 1 left. We factor by grouping. That's the techniques of factoring by grouping. If for some reasons you forget how that one work, you can go back and watch the previous video on section 5.3 and 5.4. Now, we factor completely our trinomials. We can solve by setting each factor equal to 0. I'm going to change and use a different color. Let's set the first parenthesis equal to 0, add 1 to both sides. X would be equal to 1. Or 5x minus 2 equal to 0. If we add 2 to both sides, 5x would be equal to 2. Divide by 5 on both sides, x would be 2/5. Those are the answers, not the solutions. Remember, always go back to the original equations to check if the answers are solutions to the equations. Now, on the left side equal the right side, you can state the solutions by using S equal bracket. Let's put the smallest number first. The smallest number is 2/5 and 1. All right. Hope you enjoyed this. We have a few examples to cover. Here again, I believe you need to distribute again. Remember, when you have a monomial times a binomial, first of all, you do use the distributive property to do 4x times 8x, that give you 40x squared, and 4x times 9 give you 36x equal 5. Now bring all your terms to one side so you can set the whole trinomial equal to 0. We can subtract 5 from both sides. Now we end up with 40x squared plus 36x minus 5 equal to 0. Again, each term has a coefficient, real number coefficients. We need to verify if they don't have any common factor. 36 and 5 has nothing in common, so we're going to consider they don't have anything in common. Now, with something like that, we can simply go ahead. I could just do 4 times 5 times 40 give you negative 200. Two numbers when you multiply give you 200. When you add give you 36. We could do that one with no problems. But I'm going to do trial and error again. Okay. Remember, with 40, you can write 40 multiple ways, different ways. We can 2 times 40, 1 times 40, 2 times 40. We have 4 times, 5 times 8 is 40. We have also 4 times 10 is 40. I'm gonna try to use, oh no, what a big mistake. So apologize for that. Apologize for that. That's a giant mistake. That's a giant. I take it for 9. So all right. Let's start over. 4 times 8 is not 40, it's 32. Okay. Let's go with 4 times 8 is 32x squared. And 4 times 9, yes, that's 36. Okay. Now, when we subtract 5 from both sides, we end up with 32x squared plus 36x minus 5 equal to 0. Here, I told you that there are 2 techniques you can use to solve an equation with coefficient of x squared not equal to 1. If it's not equal to 1, you can use the generic theory, for that, which is a trial and error, or you can use the AC methods. And AC methods will bring you to grouping methods. So it all depends on what you want to do. But here, I'm gonna just do trial and error as it's the most difficult one. 32, you can do 1 times 32, 2 times 16, or you can do 4 times 8, give you 32. When you do trial and error, I can try 1 times 32 first, then try something. But the problem, I realize that if I do 32 plus 5, it's not going to give me 36. So I need to be realistic with that. If I do 2 times 16, so meaning 16 plus 10, not going to be 36. So I'm going to try to rewrite it 8x by 4x. Now, because I need 36, and I need 36, but how can I rewrite -5? 2 numbers when I multiply give me -5. Remember, 5 is a prime number. Prime number has only 2 factors. 1 times 5. It's 1 and 5. So there is no other factors when you multiply would give you 5. And because it says -5, I know at one of the factors must be negative. It's either -1 times 5 or 1 times -5. But because I need 36 in the middle, I would multiply with +5 in here and -1. How to verify it's correct? Remember, this 2 would give you -4x, and these 2 would give you 40x. So -4 plus 40 give you +36. So I am certain the way I factor it, it's correct. So we call that trial and error methods. Okay. Now we factor the trinomials. We have 2 factors. We make sure there is no positive, no negative, no divisions between the parentheses. So we are certain they are both factors. We need to check on the right side and make sure it's a 0. If it's not 0, then you cannot continue. Once you verify all of this, it's okay. You set each factor equal to 0. 8x minus 1 equal to 0, then you solve. You isolate the x term by subtracting 1 from both sides, then you have 8x equal 1. Because you solve for x, there should be no coefficient to x or greater than 1. So we divide each side by 8, x would be 1/8. That's the first answer. Or you need to set the second parenthesis equal to 0, subtract 5 from both sides. You have 4x equal -5. When we divide by 4 from both sides, x would be equal -5/4. So far, I don't take any time to verify if answers are solutions because we're dealing with polynomials. Polynomials, it's, you do it the domain is all real numbers. So negative infinity to infinity, there should be no problem with that. So I just state the answer, negative 4/5, 5 over 4, and 1/8. Those are the two answers. The other things you need to verify when we solve quadratic equations, we always have two solutions or two answers. Because if you have power 2, then you have two answers. If you have power 1, you have one answer. If you have power 5, you have 5 answers. So when you solve any equations, the degree of the equations leads you to the number of solutions possible. So if you have power 2, then you have two solutions. All right, number 6. Again here, oh, this one is a little bit different. You don't have 3 terms, but you have 2 terms. One of them is power 3. So far, we haven't solved any equations with a degree 3. But you know, any equations that you need to solve, you need to factor and set equal to 0. Now, what I'm going to do is to verify from these 2 terms if there is any common factor. Both term has x, so I know x is a common factor, and both term has 3 because 3 times 4 is 12. I can prime factorization for 12 is 2 times 2 times 3. There is a 3 in it. So the GCF here is, yes, x squared minus 4 equal to 0. How would you factor x squared minus 4? In the previous section, we said if you have x squared minus b squared, you can factor it as a plus b times a minus b. And when I see there is x squared minus 4, it's the same thing saying x squared minus 2 squared. See? We end up with x plus 2 times x minus 2. So we know the 3x, x squared minus 2 squared equal to 0 is 3x times x plus 2 times x minus 2 equal to 0. What we have here so far is the factored form of a trinomial. If we have power 3, we're going to have 3 answers. Now, after factoring these trinomials, you realize we have 3 different factors. That means we're going to have 3 answers. I said this first factor equal to 0, 3x equal to 0. The only way we can set each one of them equal to 0 is because they are factors. Because I only need to solve for x, I divide both sides by 3. What is 0 divided by any non-zero numbers? Yes, it's 0. So any 0 divided by any number that is not 0 is 0. But any non-zero number divided by 0 is undefined. You need to remember that. All right. Now, x plus 2 equal to 0. If we subtract 2 from both sides, x would be equal negative 2. That's the second answer. The third one, x minus 2 equal to 0. If we add 2 to both sides, we end up with x equal to 2. Obviously, final answer would be negative 2, 0, and 2. Yeah. All right. I believe you can continue doing all of these examples on your own. But it's also important in this chapter to do to solve some problems, not only just solving equations. We're going to solve problems that involve, quadratic equations or, polynomials in itself, or how to use factoring, because some problems may be modeled by polynomial equations. So to solve these problems, we use the same problem-solving steps that we were introduced in chapter 2. I think in chapter 2 we did that. When solving these problems, keep in mind that a solution of an equation that models a problem is not always a solution of the problem. Okay? For example, the person's weight or the length of a side of a geometric figure is always a positive number. So, if you're looking for the length of a rectangle must, you either find something or nothing at all. So, that means you cannot say, oh, you know what? The length of my rectangle is -5. You cannot say that. It's the same thing if you're talking about a person. What is that person height or weight? You know, if that person exists, you cannot say that person has a negative weight. All right. Now you can always have negative if you want to express the number of pound lost by that person. That would be different. So in this case, if the answers are negative for certain type of problems, you need to reject them. All right. A model rocket is launched from the ground. Its height h in feet at time t seconds is approximate by the equations. They give you the models. You have the equations. H equal -16t square plus 112t. So that's the problems we need to solve. Plenty of things. First of all, you need the access to find how long it takes the rocket to return to the ground. I don't know if you ever throwing rocks or, something in the air, you know, in my, upper level class, we will talk about velocity and acceleration and the speed. I know we're not there yet, like when you're looking for the derivatives, first derivative and second derivative, when you have the speed, the position would give you the you know the I know the velocity, and the velocity would give you the acceleration. But in this case, let's stay at this level of intermediate algebra. That's very important to stay there. So first of all, we set the equation equal to 0 and factor it, because we can bring all those terms to one side. If I have h equal -16t square plus 112t. Remember, we want to know how long it takes the rocket to return to ground. Ground for us means 0. If we throw the rockets and then, if it's returned to ground, you can say at that point it's going to be equal to 0. So if you set h equal to 0, so that means we can say -16t square plus 112t equal to 0. What I can see here, I can factor. Is there a common factor between 16 and 112? Yeah, I think 16 times 7 give you 112, because 7 times 2, 42, 7 times 1, 7 plus 4, 11. Okay, so if we want, we can factor -16t, then you have left only t minus 7 equal to 0. -16t equal to 0. If you divide both sides by -16, t would be 0. Okay? Or if you do t minus 7 equal to 0, if you add 7 to both sides, you would end up with t equals 7. No. Our goal here is to decide how long it would take the rocket to return to ground. We cannot, 0 is 0 second, and 7 is 7 seconds. You cannot say it would take only 0 second to return to ground when you launch a rocket from the ground and then go travel in the air to come back. So you cannot say it takes 0 seconds. So the most realistic answer here, we would say the rocket returns to ground 7 seconds after launch, right? So realistically, the answer is 7 seconds, right? So the seven when you solve, it's in second. Another problems, this problem we're gonna deal with it all the time, but um, you know, most of the theorem or theory or formulas in mathematics uh, are named after the inventors. One of the most common and popular theorem in mathematics is the Pythagorean theorem for a right triangle. In a right triangle, we said the sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. So the hypotenuse in this case, remember that's very important, this problem, because we said if you have any right triangle, if you remember what right triangle is, right triangle, one of the angle is 90 degrees, and that's why we always put this one just to be sure. So the shortest length would be AB here. Let's call the hypotenuse. The hypotenuse is the diagonal. Okay, the hypotenuse is the diagonal in your right triangle. Now, the Pythagorean theorem, what it says, in a right triangle, the sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. So we're going to say that a square plus b squared equals c squared. That's really the Pythagorean theorem. And I said this is one of the most popular theorem in mathematics. And most of the theorem or formulas we're using nowadays to solve real life problems, the formulas were named after the inventors. Most of all, XY plane. In English, we call it most of the time XY plane, but we call it Cartesian coordinate plane because the guy who invented that for us is René Descartes, and he was a French scientist, mathematician, philosophers. We have so many of them like that, like Pythagoras was, like Gauss was, like Pascal. We have so many of them. We use their formulas in mathematics to solve problems. Now, let's go with another problem. Probably this one would help us to use, Pythagoras. Find the length of the shorter leg of a triangle, of the right triangle. First of all, let's tell right triangle, meaning one side. I mean, there is a 90 degrees angle in it. So at least one of the angle is 90 degrees. Find the length of the shorter leg of a right triangle if the longer length is 10 miles more than the shorter length and the hypotenuse is 10 miles less than twice the shortest leg. Okay, that's a, that's a lot. Okay, first of all, sketch a graph. Always sketch one. I'm gonna do a big one because I don't know exactly what we're going to find. Let me do that one. Very straight. Okay, I prefer to sketch a right triangle. Okay, let's suppose this is a right triangle. I'm gonna use this one as a right triangle. We're going to go step by step. The first step, they said, find the length of the shorter leg of a right triangle if the longer leg is 10 times less than the shorter leg. Now, what is the longer side? We said shorter leg. Okay. Now we have longer leg. and we have the hypotenuse. Now, um, um, a triangle has three sides anyway. So now, okay, the hypotenuse. Okay, first of all, what is the shorter leg? We don't know it. I'm gonna call it X. I'm gonna call this one X. Now, the longer leg is 10 times more than the shorter leg. That means it would be X plus 10. That would be the shorter leg. Now, they said the hypotenuse is 10 times less, is 10 miles less than twice the shorter leg. So 10 miles less. Okay, so twice the shorter leg minus 10. So we know each side right now, x plus 10 and 2x minus 10. Okay, when you solve a problem, in general, you solve a problem, the first thing to do is to read the problem multiple times. After you read the problem multiple times, you understand the problem, because one lecture is not enough. You need to read it multiple times. After you read it one or two or three times, you need to identify what is asked to find and what is given. So that means what are the facts and what are the variables. Now, once you do that, you need to translate these in terms of the mathematical models. Then once you have the mathematical models like in equations, you need to solve for the variables. You verify them in the original equations, and you state this answer or the solutions. Now, when they ask us to do that, because they said it's a right triangle, we know for right triangle A, B, and C, C square equal A square plus B square. Now, that means if I go with 2x minus 10 power 2 equal x square plus x plus 10 power 2. That's it. I need that. I need that. Now, techniques to remember, A minus B power 2 is A square minus 2AB plus B square. So those are the square of the difference we told you before. And then we have A plus B power 2. Those properties, I always suggest that you bring them with you everywhere you go. Especially, you can put them in notes or, in a cheat sheet so you should remember where they are. Now, the first term power 2 would give me 4x squared minus 2 times the first one by the second one. 2 times 2x give me 4x times 10 give me 40x plus the second one power 2. 10 power 2 is 100. I'm done with that side. 4x squared minus 40x plus 100. All right, now on the right, I keep my x squared. Then I need to do the first one power 2 is x squared plus 2 times the first one by the second one. 2 times x times 10 give you 20x plus 10 power 2 is 100. If you want, you can simplify on both sides. I end up with 4x squared minus 40x plus 100 equal 2x squared plus 20x plus 100. What I can see here, if you try to bring all the terms to one side, you can do it one by one. For example, if I subtract 100 from both sides, if I subtract 20x from both sides, and if I subtract 2x squared from both sides, because I need to bring all the terms to one side and set the equation equal to 0. All right, let's see what we have left. 4x squared minus 2x squared, we have 2x squared left. Negative 60x 100 minus 100 is gone. We don't have a lot. Now, over here also, we can factor 2x, so we have only x minus 30 left. Set each of them equal to 0. 2x equal to 0 divided by 2 from both sides. X equal to 0. And x minus 30 equal to 0, adding 30 to both sides. X would be equal to 30. Okay? Now, that should be our answer. We can interpret the answer if we want. Remember that x is supposed to represent the length of the shorter leg. If you choose x equal to 0, you know, although x equal to 0 satisfies the equation, but it cannot be a solution to this problem because we cannot say that 0 is the length of of one side of our rectangle. That means that rectangle, that triangle doesn't exist. Okay, but if we let x equal 30, then x plus 10, that means this is 40. 2x minus 10, would be 50. Then you see that plugging it both sides, you would end up with 502 equal 502. Okay, so that's something like that. So the Pythagorean theorem, checks that out. So we can state that the shortest leg, we have enough space, the shortest leg is, the length of the shortest leg, is 30 miles. That was the question asked. What? Find the length of the shortest leg. The length, let me put it here, the length of the shortest leg. So, all right, hoping you'll get this one correctly. One more examples, right? Because the third objective was to find the x-intercepts of a polynomial functions. I'm hoping you can use all these examples I covered in these sections to complete assignments and get ready for the test. But you know what? How about with finding the x-intercept of a polynomial? So recall that to find the x-intercept of the graph of a function, first of all, you really need to let the function equal to 0. If you want to find x-intercept, you set y equal to 0, or y is the function. If you want to find the the y-intercept, you set x equal to 0, so which shouldn't be a problem. The solutions of a polynomial's equations are the x-intercept of the graph of the related functions, and that the x-intercept of the graph of a polynomial functions are the solutions of the related polynomial equations. These values are also called roots or zeros of the polynomial. So whatever make it equal to 0. So very quick look at this one. If we ask you, match each equations with its graph. The first thing to do with the first option, if you set for f of x, is you set each of them equal to 0, x plus 1 equal to 0, subtract 1 from both sides, x equal -1, and x minus 3 equal to 0, add 3 to both sides, x equal to 3. So where do you feel like, the graph intersect the x-axis at -1 and 3? -1 and 3. Yes, that's -1 here. That's 3 and here. So for B, f beautiful x of x equal x plus 1 times x minus 3, because our goal is really to match each of them to the equation. Now, the other one I can do to go faster is h. For h, x equal to 0, x minus 1 equal to 0, that means x equal to 1. x plus 1 equal to 0, that means x equal to -1. Look at the other two graph left. Where do you see the graph, the blue graph, intersect the xy plane at -1, 0, and 1? Which graph? A, B, or C? I mean, we already pick up B for f of x. About H. Yes, that would be C because this is -1, 0, and 1. So we can say h of x here would be equal to x times x minus 1 times x plus 1. That's the answer. Now, do you really need to go over the last one because you're going to have a 5, you're going to have a 1, and you have a -1. So -1, 1, and 5. Set each of them equal to 0. We end up with g of x to be a x minus 5 times x minus 1 times x plus 1. Okay. I believe we're gonna enjoy next time in a different video, new chapter, rational expressions. In the meantime, hope you enjoyed this one, and then do not hesitate to send me an email if you have any questions. And I'll see you in the next video. Take care.